All right, so this video we're going to talk about the fourth of the conic section called hyperbolas. Hyperbolas are defined as a set of all points on a curve for which the difference of the distances from two given points is a constant. And what we're talking about with the two given points are the foci. All right, not a parabola. Hyperbola has two branches, two curves, two vertices, two foci. It also happens to have two asymptotes. And so what we want to do is kind of break this down. So we can have hyperbolas that open left, right. And that's going to be if the x squared function or fraction is positive. Generally, it's considered the first one. And then you can have a hyperbola that opens up and down. That's going to happen if the y squared fraction is first or positive. So just be careful about those. Let's get in and talk about some parts. Okay, and I'm just going to focus on this one. It mirrors with the other one. So you have the center, which is your HK, which should be very familiar. All right, so this is your center right here. You have your vertices, okay, which don't particularly have any specific values to them, but this is a vertex here, vertex, and this is a vertex here. All right, then we have the foci. Okay, so focus here and focus here. There we go. And we also have the A, B, and C values. So got to be careful here. So A is going to be the distance from the center to your vertex. Okay, so this is A. B is going to be the distance from the center to this, I don't know exactly what it's called. I think it's a complementary vertex or something to that effect. But basically you'll notice there's a little rectangle in the middle that we draw. That's going to help us draw our asymptotes. Okay, so there's B. And your C value is going to be from the center to the focus. There's C. All right. Now, a couple quick things that I'm going to keep adding to this pretty little picture here. The line segment that connects the two vertices, okay, and I'm going to actually put the little highlighter mark there. That's called the transverse axis. Okay, so the two vertices are the end points of that axis. And then if I go perpendicular to that, this B value here, if I connect across that, use the highlighter mark here, that is called the conjugate axis. Okay. And so the transverse axis and the conjugate axis create this rectangular box that we are going to use to create the asymptotes that will help us graph these. Okay, so that's kind of the breakdown of all the information there. Let's actually get in and talk about a few things with A, B, and C to help us out with. Your A value isn't always greater than B. But it is always with the first, and I'm going to put in parentheses, the positive fraction, okay? The graph always opens in the direction of the first fraction, and again, I'm going to put in parentheses positive, because I have seen equations written where the negative value comes first, so just be careful. The relationship between A, B, and C is going to be defined by C squared is equal to A squared plus B squared. All right. So let's actually get into doing some graphing here. All right. So first thing I want to do is identify the center. So remember your HK. h is always associated with x, k is always associated with y. It doesn't matter which one comes first. So this is going to be 7, -3. So let's go ahead, 5, 7, 1, 2. All right, there is my center, okay? So a isn't necessarily greater, but it's always with the first fraction here. So this is, 16 is a squared, and 4 is going to be b squared. So if we square root those, a is going to be 4, and b is going to be 2. So what this is going to help me do now, so my first fraction here, my positive fraction is the y squared fraction. So I'm going to count from my center up and down 4 units. 1, 2, 3, 4. 1, 2, 3, 4. And what I've just marked here is the end points of the transverse axis. So those are actually your 2 vertices. So my vertices here, I'm going to go ahead and write those ordered pairs. So that's going to be 7, 1 and 7, what is that, -7. Okay, so those are my 2 vertices. Now I'm going to count from the center 2, that's my b value, on the conjugate axis. So I'm going to go perpendicular, 2 here, 2 here. Okay. So this is going to create, I'm going to zoom in just a little bit so I have a little bit better. There we go. All right. So I'm using a green highlighter here to mark out basically a little rectangle. And the reason I mark that rectangle is that if I now connect the diagonals of that rectangle, that is going to give me my asymptotes. And then using those asymptotes, I can connect the dots. Well, it's not really connect the dots, but I can at least associate the curve with what makes sense using the asymptotes. All right, so let's actually go ahead and connect this up. So I'm going to follow my asymptote. I'm going to curve down to the vertex, curve back up, and follow the asymptote out. A little shaky there, but that's okay. Do the same thing with the other branch. There we go. So we've got the curve now. Now we need to figure out the focal length and the foci. So focal length is going to be c squared is equal to a squared plus b squared. So c squared is going to be 16 plus 4. So c squared is 20, which makes c equal to the square root of 20, which would be 2 root 5. Yeah, that sounds right. But as far as I'm concerned, counting out 2 root 5, not terribly helpful. So if I throw that into a calculator, let's see what decimal equivalent I get here. About 4.5. So c is approximately equal to 4.5. So from the center, I'm going to count up along this transverse axis, but then I'm going to go beyond the vertex here, 4.5. So this is 1, 2, 3, 4, and that gives me a focus of right about there. And I'm going to mirror it on the other side. Okay. So just like a parabola curves around the focus, so does a hyperbola here. So make sure that the foci are within the curve, not within the rectangle. All right. So my actual 2 focal points, the x value is the same, but what I'm going to do now is take -3 and I'm going to add 2 root 5 because I want the exact values here. And then I'm going to do -3 minus 2 root 5. And that will give me the exact points for my 2 foci. All right, I'm going to go ahead and slide over to number 2 and we're going to do the exact same thing. Only let's see if this one, yep. Because the x squared is first, this hyperbola is going to open to the left and to the right. So first things first, let's get a center. That's going to be 5, 0. So let's see, 5, 0 is right here. A value, so this is a squared, this is b squared. So this is going to be 3, that's going to be 5. All right. So because x comes first, I'm going to go ahead and count the transverse axis along the horizontal. All right. So from the center, I'm going to count 1, 2, 3 to the right, 1, 2, 3 to the left. And those 2 points that I just marked are my vertices. So I'm going to go ahead and actually mark those and tell myself what they are. So 2, 0 and 8, 0. And then I'm going to use 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay, so there's my conjugate axis. All right, the endpoints of the conjugate axis. Now, I'm just using the highlighters to make it really clear what is my asymptotes versus what's my not asymptotes. You can obviously use pen or pencil. It won't, make much of a difference. Just make it clear when you do this that you don't connect all of these with solid lines, because that would imply to me that you think that those are supposed to be part of the actual curve. This rectangular box is just used to help us make the diagonals. Okay. And those diagonals are then used to help us draw those asymptotes, because those are what the diagonals are, our asymptotes, are used to help us draw the actual curves. Okay, so there we go. All right. So the actual curves here, remember this opens left and right because it's x squared. So we're going to start here, curve up towards the asymptote here, curve up and towards the asymptote here. Repeat the other side. Here we go. And there we go. All right. So now we need a focal length and we need some foci. So focal length here, we're going to do c squared is equal to a squared plus b squared. So what would that be? 34, I think. Yeah, that makes sense. 9 plus 25 is 34. All right. Let's see. Dividing. Nope, nothing helpful there. So square root of 34 cannot be simplified, but it can be approximated as 5.8. All right. So along this transverse axis, I'm going to count out 5.8 to figure out where my 2 foci are. So from here, let's see, 5.8. And then we're actually, I think, going to go off the graph with this one. 1, 2, 3, 4, 5. Yep, we are, which is okay. All right. So the 2 little purple dots are my foci. Make this one a little bit bigger. All right. So where are those? Well, we obviously changed the x-axis. So we're going to do 5 plus root 34 and 0. That's a 34. There we go. And then 5 minus root 34, 0. All right. So there's our 2 foci. And problem number 2 is done. All right, I'm going to go ahead and slide on down to number 3 here. Repeat the process. All right, so let's see what we've got here. We've got x squared, and that's going to be meaning we're going to open left and right. So our center is going to be -3, -2. This is a squared, this is b squared. So a is 1, b is 6. All right, so -3, -2 is my center. On the horizontal, in this case, is going to be the transverse axis. I'm going to count 1 in each direction. There's my 1s. Those are my vertices. So this is going to be -2, -2, and -4, -2. And then I'm going to count 6 on my conjugate axis. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And now I'm going to use those 4 points to create that rectangle, which will let me draw in my asymptotes. There we go. All right, so this is seriously steep going on here. And I don't exactly have a ruler here for my notability. That's what I was trying to get at. My brain just stopped for a second there. All right, so we have x squared first, so we want to make sure we're opening left and right. Let's go ahead and graph this in. This is a really, really open hyperbola here. All right, repeat it on the other side. All hyperbolas have two branches to them, so make sure you always draw both. The last piece we're going to do here is our focal length. So it's going to be c squared is equal to 1 plus 36. So c squared is equal to 37, which makes c equal to the square root of 37, which is approximately equal to, what would that be, 6 point what? Let's find out. 6.1. Okay. So on my transverse axis, which in this case is the horizontal one, I'm going to count 6.1 units from the center. 1, 2, 3, 4, 5, 6.1-ish. And then if I do the same thing on the other side, 1, 2, 3, 4, 5, 6. Hold on, I just lost my count there. 1, 2, 3, 4, 5, 6. Again, a little bit off the graph, but that's okay. So those little blue dots are our two foci. What changed was the x values of the foci, not the y. So we would do -3 plus root 37 and -2. And then -3 minus root 37, -2. All right, one more to go. And then we'll close this video out. So problem number 4, we got to graph another one here. We've got y squared first this time, so we're going to open up and down. Let's get our center here. So we've got 5, 0. All right, so whoops. Let me make my graph go fly in there. All right, so 5, 0. We've got a squared, we've got b squared. So a is 2, b is 3. So I'm going to count vertically from the center, 2 units up, 2 units down. Those are now my vertices. So that's going to be 5, 2 and 5, -2. I'm going to count horizontally for my conjugate axis, 3 units in each direction. 2, 3 units. Play connect the dots to create the rectangular box here to get my asymptotes. Okay, so there's one asymptote. Let's go ahead and graph in the other one. Obviously on paper, I would highly recommend using a ruler, or even a straight edge would be great with these, but sketch it in as best you can. All right, so our graph here is supposed to open up and down. So from my vertex, I'm going to approach the asymptote here, vertex approach the asymptote here, repeat on the right, or the bottom part of the branch here. And the last piece we're going to do is our focal length. So c squared is equal to 4 plus 9. So c squared is equal to 13. That is a horrible 3. Try that again. So that means c is equal to the square root of 13, which is approximately 3 point something. Let me grab that calculator here. 3.6. And the reason I give myself that decimal is just so I can count it out on the graph and make it look approximately where it's supposed to be. So 1, 2, 3.6. 1, 2, whoops. 1, 2, 3.6. Had to make sure I was counting from the right space. So in this case, our x value didn't change, but our y value did from compared to the center. So that's going to be 5, what would that be? Well, that would be root 13, and then 5, negative root 13. All right, so I'm sure this was a relatively long video to catch all of this information on how you graph hyperbolas. In the second video, we'll reverse the course and we will take all of our graphs and turn them into equations. If you have any questions or concerns, let me know. Send me an email or a message